Ready? Good morning, everyone. Today we are going to discuss about the interference. So, first interference. Interference means when two waves, two waves are traveling in the same medium, one after another, right? So, when these two waves are traveling in the same direction, constructive, constructive superposition. So, when two waves are traveling in a same direction and these two waves are to be added, then that process of superposition is known as constructive superposition. If one wave is traveling in this direction and another wave is traveling in opposite direction, so the resultant will be destructive superposition. Destructive superposition. So this change or the modification in the region of superposition is known as interference. The modification in the region of superposition is known as interference. Now, according to your syllabus, we need to discuss the interference pattern. Interference in thin films by reflection process. So for this question we need to know about this diagram first. Understand this diagram first, and then you will conclude all the interference pattern in between two rays, right? So when this is the plate which is called as G and H is the top plane, and G dash and H dash is the another plane. Now A is the ray, which is incident upon the G and H plane and taking reflection from the point B and reflected as ray 1. So when light is incident upon a transparent material, some of the light will be reflected and some of the light will be refracted. So the refracted ray will meet this point C on the plane G dash H dash, and again it takes reflection from C and meets the point D on the top plane again, and these two waves are said to be interference, following the pattern of interference. So here interference, for the calculation of interference we are using the formula delta, or the path difference between these two rays will be calculated as, here the distance between these two plates, glass plates, is nothing but small t, and the refractive index value is mu, because rarer medium and denser medium are separated, so that mu will be calculated. Here the extra distance travelled by the second ray, will be equals to from B to C and C to D. So the extra distance travelled by the second ray, by adding the refractive index of the thin film, and this is equals to BC plus CD. Here the first ray will travels extra distance because the second ray will enters into the medium and taking reflection and then emits out. But before that, the first ray will travels an extra distance. The extra distance will be calculated to draw a normal from D, which is known as position B. So the BE is the extra distance traveled by the first ray, while the second ray will travels in the medium. So BC plus CD minus BE. So we have to calculate or find out BC value, CD value and BE value. We will get the interference formula. So for this, we have to understand this diagram first. So for that, I am taking a normal from here to here. So this is F. The incident angle is always I and the refractive angle is always R. So from triangle BFC, so from triangle BFC, take the value of R. So cos R value is equals to, what is cos R? Adjacent side BC by, adjacent side is CF by hypotenuse BC. We know that the distance between the two thin films is known as small t by, we don't know the value of BC, so BC value is equals to, that implies BC is equals to T cos R. BC value is equals to cross multiplication T by cos R. This is equation number 1. We have find the BC value here. So from the second diagram, from the second triangle, from triangle CDF, cos R value is equals to, again, so this is also R. When cos R from this triangle, adjacent side is CF and hypotenuse is CD. So again, from the diagram, the diameter of the thin film is equals to small t, that is nothing but T is equals to CD value is nothing but T by cos R. So from the above equation, we deduce BC value and CD value. Now we have to calculate the third triangle. This is incident angle. So here we have to find the BE value. For that, remember this thing, always the refractive index value or refractive angle is always considered in a cos values, and the incident value is always in the form of sine. So from triangle BED, from BED, see this BED. So from triangle BED, what value we have to conclude? We have to conclude sine value. So from triangle BED, sine I is equals to, what will happen? See this. Sine value means opposite side by hypotenuse. Opposite side is equals to BE by hypotenuse value is BD. So sine I is equals to BE by BD. But here we don't know the BE value. At the same time, we don't know the BD value. For calculating the BD value, for calculation of BD value, we need to use the below triangles. Below triangles. What are the below triangles? From BFC and CDF. From these two triangles, we have to calculate tan of R value. So from triangle BFC, tan R is equals to see this again we are going to diagram. So from BFC, tan R means opposite side by adjacent side. So opposite side is equals to BF and adjacent side is equals to CF. So tan R value is equals to BF by CF. So BF by CF means CF value is always the thickness of the thin film, so that it is T. So BF is equals to, when T comes over here, T tan R. So BF value is equals to T tan R. Keep this value in mind. And from triangle, next triangle is CDF. From next triangle CDF, so tan R value is equals to, what is the tan R from the triangle? From FDC, tan R opposite side by hypotenuse, opposite side by adjacent side. So that is equals to FD by CF. FD by CF. So tan R is equals to FD by CF value is equals to FD by T. So this is nothing but FD value is equals to T tan R. So second value. So here from the diagram, CF plus FD value is equals to, BF plus FD value is equals to BD. Endukani? According to the diagram. Okay. So now we have the value of BD. We have to calculate the BE value. So from this, we have to calculate sine I is equals to, from triangle BED. What is the values of sine I? Sine I is equals to BE by BD. So from these two values, BD is equals to BF value T tan R plus FD value T tan R. So this is equals to T tan R plus T tan R is equals to 2T tan R. So from this, sine I value is equals to BE by BD means 2T tan R. So from this, BE value is equals to BE value is equals to ఏమవుతుంది 2t tan r into sin I. 2t tan r into sin A. So at any cost there is no possibility of incident angle and refractive angle both are existing in a same plane. So we have to convert this I value into r's in terms of r's. For that we are using Snell's law. From Snell's law, what is the Snell's law? Mu is equals to sin I by sin r. So sin I value is replaced with mu sin r. Sin I is replaced with mu sin r. So BE is equals to 2t tan r into sin I will be replaced by BE is equals to 2t tan r into sin I will be replaced by mu sin r. Okay, understand? Right. So this can be written as 2 mu t tan r into sin r. So now we have three values. First value is BC value. What is BC? BC is equals to t by cos r, and second value is CD. CD is equals to t by cos r, and BE is equals to 2t tan r into sin r. So 2 mu t tan r into sin r is the BE value. So from these three values will be substituted in the formula. What is the formula? Again I am writing the formula for finding the path difference will be equal to delta is equals to mu into BC plus CD minus the extra distance travelled by the first ray will be equals to BE. So see this, mu into BC value is equals to t by cos r plus CD value is equals to t by cos r minus the value is 2 mu t tan r into sin r. So this is equals to 2 mu t by cos r minus 2 mu t tan r into sin r. So now I am writing this expression as 2 mu t by cos r minus 2 mu t into sin r by cos r into sin r. Can I write it? Yes, I can. So now take the common positions. 2 mu t by cos r will be taken out from these two terms. 2 mu t by cos r commonly taken, so that it will be replaced by 1 minus 2 mu t by cos r will be taken out. So sin r into sin r, sin square r, right? So 2 mu t by cos r. So here 1 minus sin square r. See, sin square r plus cos square r is equals to 1. So from this, cos square r is equals to 1 minus sin square r. This is trigonometric rule. So this will be replaced by cos square r. So e cos r e square get cancelled, and finally we have 2 mu t cos r. This is the path difference for finding the light value in a thin film. So this is known as cosine law. Cosine law. In your examinations, the examiner can ask derive an expression for derive an expression for derive an expression for interference in thin film. So ఇది 7 మార్క్స్ అడుగుతా ఉంటాడు. Very important question. This is the thin film expression. Clear?